How's it going, everyone? Welcome. Euler Gonzalez here, and today I want to explore about the chapter 3, digging into the roots of JavaScript. This is a book written by Kyle Simpson, a software engineer with over 20 years of experience that has worked at several companies. And so he made this book, right? Because JavaScript developers, including myself, we tend to not take this language so seriously. Like, for example, any other developers, C Sharp, Objective C, Java, Python, and most of them read the docs, read the spec. And JavaScript, because this toy, quote, quote, a language, because it's not considered a true language due it is dynamic nature, especially because it is an interpreted language, which the reality is that it's not. It's a compiled language. Why am I saying that? Because the way how now it evaluate errors. So pretty much like any compiled language where it's going to process your document entirely for any errors, and if there are any errors, so it will throw that, right? And if it's not, it's going to convert that into, it's going to tokenize all of these keywords and operators and identifiers, and then construct now an abstract syntax tree, which is this representation for humans and machines about how this program looks like using this data structure. All right, and then it is going to compile to usually a binary portable for that distribution. Okay, so because this is not what happened with JavaScript, and therefore when when the JavaScript engine receive a file, it turns out that that file is parsed, and this parsing phase is when this early errors happens. You can take a look at the docs and check out the static semantic, all right? For example, for functions, for generators, among other features as well. But it turns out that there are several features in JavaScript that pass through this process. So because of that, if not in essence, if not in practice, JavaScript is a compiled language. But in any case, this is not the today video, because I do want us to talk and explore of this chapter 3, this digging into this root, into this low level characteristic of JavaScript, a language that it is virtually in every line of code we write, right? So first things we understand is the iteration, what the iteration is, what is the logic behind that, and if you want to now consumes data one at a time and process that to make decisions on that, which is usually what we want, what these programs are built for. Well, iteration pattern, which is something that's not unique to JavaScript, is part of this design patterns. Design patterns like the creation, structure, and behavioral. So iterator is a behavioral pattern, right, that allow us to have this standard way of of approaching to this problem, and now have a consist way to read this code and to maintain that, right? So this is the reason why I'm looking at this, and to actually understand and to connect all of these dots. So we also have another patterns, for example, like the creations as the factory or the prototype, the builder, And in the structural, we have is the adapter, we have is the bridge. I would like the adapter, the bridge. Mm, how do you what the French does? The adapter, the bridge. This is the sign pattern. Um, in the structural, I have the adapter, the bridge, the decorator, all right, as well as the proxy. Interesting, because all of this design patterns now change how to assemble objects and classes into large structure while keeping this structure flexible and efficient. It's like how you can now uh, assembling different objects, pretty much like Lego blocks. Okay, how you can assemble different Lego blocks into large structures. So, for example, the adapter, the bridge, and most of the time is the decorator, uh, the facade. Provide a simple interface to a library, a framework, or any other complex set of uh, libraries, right? The real world analogy. When you call a shop to place a phone, an operator is a facade to all the servers and department of the shop. And so, but most likely is the facade, the decorator, which is something that is heavily used in Angular, for example, is that hey, you want to attach new behaviors to this object, all right? Uh, or the facade, where you want to expose now something. When you call a shop to place a phone order, an operator is your facade to all of the service. All right. So calling is a customer service is a facade. If you want to place an order, and the proxy as well, which now this allows you to is intercept the object in itself. Okay, lets you provide a substitute or placeholder for another object. A proxy control access to the original object. So this proxy object is something like that. But it all of them is now is a way to compose those data structures. It's a way to compose. It's a way to assemble. Um, yeah, it's a way to assemble objects and classes into larger structures. Whereas in the creation is a way to provide object creation mechanism. This is quite interesting because here is describing is a problem that each one of them are having. If your challenge is how do I create now objects, there are several mechanisms or patterns to do that, whether it's a singleton or a prototype or a factory, right? And if your problem is more about how you compose different objects into one or into a large structure, this is known as this structural design pattern. So, for example, how do I compose this one particular library with another, and how do I communicate that? Okay, so for example, the iterator that say, hey, you have different. If you have incompatible interface, let's go to create now a layer to do that. The other is the bridge. The other is a decorator. The decorator is something that I'm quite familiar with. The decorator, which lets you attach new behaviors to objects here. The facade is to provide a simple interface for a library on a framework or any other complex set of classes. The fly wave, that feeds you more objects into an available amount of RAM by sharing common parts or state between multiple objects instead of keeping all the data in each project. The other is a proxy. It's like, hey, I'm going to act as a control access for the original object and allow you to perform something either before or after the request gets through. Okay, so all of the and also the behaviors, right? Where they say, hey, the most common is the iterator, right? And this is now behavior design pattern and concern with algorithm and the assignment of responsibility between objects. Who is this object responsibility and what is the concern of this? So what this algorithm is doing. So when you have now problems about or questions about what this about the algorithm, what this algorithm is doing, and the assignment of responsibility, now you have is this behavioral design pattern. So I am more familiar with the iterator and the observer, okay? And also is a state. Let's add an object alter its behavior when it is internal state change. It is appear as if the object change, it is class. The button and switches in your smartphone behave different depending on the current state of the device. When the phone is unlocked, when your phone is locked, when your phone's charge is low. Pressing any button shows the charging screen. But again, all of this, alright, all of this are ways, okay? So all of these different patterns are way to now understand what is the problem here that we're trying to solve. And when it comes to algorithm, or when there's a concern about the algorithm that you're gonna make or the responsibility of this between objects, now these particularly patterns are useful. So for example, if you're concerned about how you're going to consume data, all right, or eventual data from that, and when that data now change, you want to get notification of that. That is an observer pattern here. Or if you are concerned about is that you want to make these algorithms to walk through all of these different data structures, all right? This is now about is the iterator behaviors. Again, I am more quite familiar to that chain of responsibility. I am more quite familiar is to the iterator, the observer, and the state, all right? Which is React is heavily using this particular pattern. They use a family of algorithms, put each then into separate class and make their object interchangeable. And the template method, the visitor, and so on and so forth. But in any case, this is at least to describe this particular pattern. And in the iterator we have here is this convention to do, right? So the iterator, at the end of the day, is just an algorithm that is pointing to have a reference to the underlying data structures, the data source, and now expose some methods called next that you can call, which give you now the value. And if this is the end of this collection, right, as a boolean. So here in MX script, we have now a different way of how can we consume these iterators. So for example is the spread operator and the for of loop. And what they're doing behind the scene, especially the spread operator, which say, hey, if this expression that you are passing to me, whether it's an assignment expression, is a conditional expression, short-circuiting if, or an ternary operator, or the nullish collision, right? Or if there's an arrow function on async arrow function, but at the end of the day, they produce now is a value that internally have under the prototype or in its own property, it has the symbol.iterator, a well-known symbol, which is a particular value that points to internally, that has a reference to say, hey, yeah, this object, this value is implementing or is able, is it has this protocol implemented, right? So and the way to now define is the data source or these iterables, right? Which is this collections that can be iterated over. Here in JavaScript we have several of them: string, maps, key, map sets, arrays, and the other is that when it comes to look at different features in JavaScript, which is a closure, and how closure actually works, which is, hey, at the end of the day, the closure in itself is when the functions continue to have access to variables and have a reference of them from the outer scope in the inner scope, even after that function is run in a different scope. So there's a couple things here, because it say that closure is going to hold the reference of those external variables that is being used inside of the function, and no matter which scope you are going to execute that, you will continue to have that reference. So there are here, well, traditional way of how can we create functions. For example, when you return now a function, but it turns out that this is not only exclusively for functions, returning functions, but also is, for example, is when you're passing is a function's definition to a function call that is wrapping a function. So this is indeed creating now a closure, all right, of that variable that is closing over, which means is that creating is a reference, which means is that that reference is going to live as long as that functions live, all right? So if that function, for example, if you want to release memory from that, so one way to do that is by now assigning that to a null, right? So whoever create that closure, you're going to assign that to null. This is also true, for example, when you're going to pass now is functions declarations. When you're going to iterate to functions, when you're going to iterate through, for example, a collections of elements that you pick from the DOM, a bottom, and then you want to add now to each one of those buttons an event listener click and a function for that. And how when you use now var or let, the difference matters. So for example, in the var and let, var is now globally scope, whereas let is block scope. So anytime that you're using a for and then you pass down to this block iteration, essentially you are creating is a new variable on each iteration, right? So the reference remains here, unlike the var, where it's going to pass is the reference of the last value that holds. So this is just to understand now closures. And the other is the this value, which, because closures is now when a function's in. So we look that a closure is created. So we look that functions attach functions definitions attach an enclosing scope via closures, okay, and this is one of the features of the functions, because the other is that it has access to a particular object known as the the execution environment, sorry, the execution context, which internally, this execution context has access to the realm, which is a global object that you can have access to. It also have internal property like functions, and script or model, and the code where it's going to execute it, right? Again, this is just internal definition, but it turns out that this value that you can have access in the functions, via this value is the execution context. And because this is happened at runtime, the value determined is at how you call that function. So if you call that function is exactly determine how you call that function. So the value of this is not determined is by whatever is on the left side. This is false. Not only, or determine is, yeah, most of the time that's not true. So when you call this function, the value of this will be determined is at runtime. So for example, if you define now if you have a reference to this, and you want to get a reference using this value, so you can have access to the execution context at that moment. And if that moment that doesn't exist, well, it's gonna throw you an error. And the other is that, if you, for example, now have a value of this, all right? If you're defining a function, again, this is a function property, not an object, okay? Not an object. Since, not an object, not an object. Makes a lot of sense. Not an object, not an object. Since this program is not in a strict mode, so the value of this, okay, and the assignment, if you're gonna call this topic, so the value of this resolves to undefined in this particular case. So imagine now this, right? When you pass now a function, and inside of that function have access to this particularly, have access to this execution environment. And if for some reason you're making a reference to that execution environment and that reference doesn't exist, it will throw you an error, right? So the way this is determined here, okay, this is pretty much like you are now. Here is this is pretty much like you're saying something like that. You copy this function and then you paste this function here, right? I do think that you shouldn't do that, but I'm afraid that there is a lot of the time this is what's happening here. A lot of the time this is what will happen here. Function study is you're gonna paste these things, and then you're gonna know what it is, and then you look at that assignment, you say, oh, this is a function, and this function is calling is this, right? So in this case now, the value of this, because it has access to this execution context, all right? And this execution context, when you do things like this, is gonna be provided this, so that this value is like providing is these objects, right? So a copy of the assignment function reference is set as a property of the homework object, and then it is called as a homework.assignment here. This means that the this for that function call will be the homework objects. Hence, this .topics resolve to JavaScript. Lastly, all right, the other way of how you can do that is by saying, hey, when I call this, okay, when I call this, I want to now I want to define as a value of this keyword, okay? So to define that value here, you can just say, hey, other homework for that. So a third way to invoke a function is with the call methods, which takes an object, other homework here, to use for setting this reference for the function call. The property reference this.topic resolved to math in this case, right? Because now you are, this is the way of how you can now is set the value of this execution environment, which is this is the way how you can set the value of this execution environment that you can have access using the this keyword. Okay, this might be a wonderful topic to practice, because I do find that this is something that in JavaScript is quite powerful, all right? When it comes to now define things that only happen is at runtime, all right? Okay, when things that happen is at runtime, exactly, and when those things happen, which is inevitable due to the nature of the JavaScript, all right? Because here we can now add some interactivity, and because the web is now in essence asynchronous, okay? You have to wait for data to be low. You have to wait for that server to reply. You have to first make a DNS server a handshake, and therefore you now have to is so you need to resolve is the URL. You need to resolve is the IP address via DNS, which is a server that has these entire records of all of these name or the streams, the URL name and the IP. So once the browser get that, okay, now let me actually establish the handshake with this server that I know where it is, right? It's like knocking the door, someone else's doors, right? It's like, it's gonna do a handshake, bro. That might be quite weird. Absolutely, especially if you're talking to somebody that you don't know. You know what I mean? That's kind of the analogy here, okay? But here they are treat them politely, all right? They knock the door and they establish the handshake, and this handshake is known as the synac ack, which is a fancy way to say, hey, is there anybody there? So this is the sync. The server reply that with synac, all right, and it's like open the door to say, hey, yes, and then you send now an ACK from the client to say, okay, I come here to talk about Jesus, and well, okay, it's okay, man. Or I come here to talk about this conversation, right? And it is pretty fucked up that anytime we say I come to talk about Jesus, it's like, oh my god. How many times people have said that? I don't know, but that will be laughable if Jesus Christ still exists, still alive, and say that is like, yeah, man, all right. But yeah, all right. So this is the synac when that handshake happens, which is since this is something that it's insecure. That's why we have now is the SSL handshake that now include is another handshake where it's going to exchange the key, so make now these communications secure or encrypted, all right? And this is not, this is for example, this is on the HTTP 1 version, and the HTTP 1.1 and the HTTP2 as well. All right, this is true for this version of this protocol. But when it comes to understand is the HTTP3, which was developed by Google, known as the Quick protocol, they say we're going to establish is the hello client and hello server. TCP here. This is the UDP. No, this is Quick protocol. Okay, which now becomes an open source general purpose protocol. All right, where you have now, this is the way how you can communicate in TCP, but with this protocol, say, hey, because there is a lot of handshake. First is the way how the way how now the browser, again, the protocol initially when it was developed, it was not considered security in its foundation. This is why they have to put this TLS. I thought that this is SSL. Well, TLS 1.2 say, hey, this handshake that we're gonna set is now to encrypt this communication here, and then I'm gonna send the data. But because now the developers and the engineers at Google say, hey, you know what? That's good. That's how we inherit stuff. Let's go now to simplify things by defining as a protocol to say, hey, I'm gonna send the initial hello from the client to server. The client say, the server will say, okay, I'm going to send you is a hello with the certificates and the finalizations. And once the client receives that, right, is able to encrypt the data and send that to the server when that request is needed. So it all what it does is to reduce the amount of back and forward things that happen here. So okay, I mentioned briefly that, but it's because is what happened here on due this dynamic nature of the of the language of the web here. So because we're communicating is with other computers, another local resource, usually. So we have to wait for that. In essence, it makes this now an async operation. So because of this, now JavaScript has shown that it's a very powerful language to deal with that. So, and because of that, when it comes to now is know the value of the execution environment and how you can define that. This is something that we do with the this keyword. We can is modify that value via the call method. The call, the bind, or the apply. Okay, the benefit of the this aware function and their dynamic context is the ability to more flexible reuse a single function with data from different objects. So no matter how this data it is, we can reuse is the functionality here. All right, this is what in essence is. So exactly, you're passing now this data at runtime, and you define this set of functionality that talk about that or that can operate on that data. It makes a lot of sense for this to be used, and there's a lot of sense for why there's too much confusion about. So a function that close over a scope can never reference either a different scope or set of values, but a function that has dynamic this context, a function that close over a scope can never reference a different scope or a set of values. Exactly. A function that if exactly a function that close over or that close over a scope or variables can never reference to a different scope of can never reference to a different set of variables. This is when it comes to scope. This is what is the static. So a function scope or a function that close over a function that close over a scope, a set of variables, can never reference a different set of variables, or scope set of variables. But a function that has a dynamic this context aware can be quite helpful for certain tasks. Okay, what task will be? Je ne sais pas. But I do find that is quite revealing here. Interesting. The other is the prototypes. So where this is a characteristic of a function execution, a prototype is a characteristic of an object. Okay, where this is a characteristic of a function execution, similar with the enclosure as well, a prototype is a characteristic of an object. And specifically, resolution of a property access. And specifically to the resolution of a property access. Okay. Think about a prototype as a linkage between two objects. The linkage is a hidden behind the scenes, though there are ways to expose and observe it. This prototype linkage occurs when an object is created. It is linked to another object that already exists. So the prototype linkage occurs when an object is created. A series of objects links together via prototype, it is called the prototype change. Exactly, a series of objects that is linked via prototype, it is called the prototype change. The purpose of this prototype linkage it is from an object B to another object A. It's so that access against B for property methods that B does not have are delegated to A to handle. Delegation of property methods access allows two or more objects to cooperate with each other to perform a task. So if this object doesn't have it is this is the core here. This is what object-oriented programming is all about. When you have a problem where cooperation and coordination is required here, cooperation, object-oriented programming is the way to solve this problem so far, right now. And consider defining an object as a normal literal. The homework object only has a single property on it. Exactly, the homework object only has a single property on it. So the homework object only has a single property on it. Topic, exactly, which is own property. However, it is default prototype. So anytime you have a problem that require is coordination or cooperation, most likely cooperation, in here, this is the way how now you can have access to certain property and methods along the prototype change. Exactly, but it's like about the cooperation here. Hey, this object doesn't have. Is this object has? No. Is this object has? No. Is this object has? No. And if none of them has, well, or you create now an object in itself that has a reference through the prototype change, through this delegation. All right. Interesting. And the homework object only has a single property on its topic. However, it is default prototype linkage connects to the object.prototype object, which has common built-in methods on it, like to string of value of. Wait a single moment. But it's this. And we can observe this prototype linkage delegation from homework to object.prototype here. Homework to string is this. Okay, because you can have access. Okay, the homework object only have a single property on a topic. However, it is default prototype linkage connects to the object.prototype object, which has a common built-in method on it, like to string and value of, among others. We can observe this prototype linkage delegation from homework to object.prototype. So for example, here to string, which is trying to coerce, to string here to say, hey, let me now coerce this value into a primitive here. Homework to string works even though homework doesn't have to string methods defined. The delegation invoke object.prototype to string instead. Exactly, because it's going to look at that. And the object linkage. To define an object prototype linkage, you can create the object using the object.create utility. Homework topic.js var other homeworks object.create homeworks. So here, this is the object linkage. So here, when you read this and say, hey, this is how you can create now, is a reference through the prototype change to cooperate with this object. I want this object to cooperate with this object. I want this object to have access to this data, all right, and functionalities. And the first arguments too is object.create, specify an object to link the newly created object to, and then returns the newly created and link objects. But exactly the entire reason of using the object.create is to establish now a cooperation to that. So hey, I want this new object that I'm gonna create and held that inside of a variable, have access to the data and its functionality as well. And let me now extend that right? So I can work is with that data. I can have access to the functions, functionality. So I don't need is to redefine that. This delegation. This delegation. Exactly. So the purpose of this prototype linkage is so that access against B of a property method that B does not have are delegated to A to handle. And the delegation of property method access allows two or more objects to cooperate that. The first arguments object.create specify an object to link the newly created objects, and then return the newly created link object here. Okay. Makes a lot of sense. Hola Jonathan, buenos días.
Hola, ¿cómo vas?
Bien, bien. Ya por lo menos hay luz en la casa. And we're back. Yep, we're back. So yeah, I do want is to continue to look at this because this is how you can now is cooperate or delegate, you know, data and functionality to other objects through the prototype change. So far so good, right? So this is it. The other is the object linkage. To define an object prototype linkage. So anytime that you want to create now an object that have access to this data and so on and so forth, well, this is what we can do here. To define an object prototype linkage, you can create the object using the object.create utility. So for example, like this. But yeah, I do have it. So it's this one, the object linkage. To define an object prototype linkage, you can create the object using the object.create utility. So JavaScript exposes you this as a way to create now this linkage, this cooperation, or yeah, this cooperation, this linkage. The first arguments to object.create specify an object to link the newly created object to, and then return the newly created and linked objects. So figure 4 show how the three objects, other work, homeworks, and object prototype, are linked into the prototype. When you create now this, object of homework has a property called prototype, which is something that all of object contains, right? And the question is that how do we know? All right, how do we know? Okay, so how do we know? This is a valid question. How do we know here? Right? By looking is at the expression statement. No, is a type value. Executable code. No. Exotic objects, medical here. No, this is more about the values. ECMAScript data type values, exactly. So how can we now here? Okay, property values. Oh, there you go. But again, this is what the specifications describe here, right? Attributes are used in this specification to define and explain the state of object properties as described in table 3. Unless specified explicitly, the initial value of each attribute is default value. So you have value, you have writable, you have get, you have set, you have enumerable and configurable. All right. Also, you have is essential internal methods. Get prototype off, set prototype off. Exactly. So get me is now the object that I have access, the link object that I have access to. Interesting, interesting, interesting. So if I say, for example, this, so if I say get prototype of, all right, uncaught token, unexpected, unexpected token. So let you say something like this. So const, this is an object, that will be this, right? And then you say here is the object, dot get prototype of. It say it's not a function. Interesting. Nope. Doesn't return anything. Okay, it's undefined, which is good. So for example, if we say now data, what if we say topic here, right? Something like this. Say topic, JavaScript. Following is this same thought. You have homework. Okay, okay. So if you have, for example, now an object called homework, topic GS, and then you have another homework. Okay. Then you have homework, and then you have is another homework, right? And here I want to create now is an object that has a reference to that, to cooperate with that object. So object.create of this reference that I manage here in this value, homework. All right. And now if I have the another homework and then I say topic, but it is interesting that by the exact topic is this. So if I want to now inspect that, say get prototype of, all right, it say that this is not a function. But if I want to get that, according to this, it say no, you don't have that. Which that to me is quite interesting. So because this is now internal methods, because here is trying to access to the own methods, but here through the prototype, prototype. Interesting. Okay. It's extensible, prevent extension, get on prototype, has prototype. So this internal method that has on property, you have is called topic. All right, has on property called topic, is not own. Okay. Own property key. It has property, has own property, or the other is that has. But it's interesting because it's like there is a mismatch here between this implementation and what it really looks like. I'll be right back. Perfect. All right. All right. All right. Good. Good. So this is what additional essential internal method of functions object. Essential internal methods. But it's interesting because it's like I cannot have access to them. You know, I cannot have access to them. Get prototype of here, but they say, hey, I am not a function. And if I call you this, like get prototype of, you say, no, I don't know you. But if I say get, of course, does not exist. But if I do go to the prototype, so if I say this, and then for some reason I'm trying to access to the prototype, okay? Okay, through this, and I can, and this is the way of how can I have access to all of the property and method. It's a has on property is prototype of property in enumerable to local string to string. This is to coerce this into a primitive. All right, value. This is to coerce. This is to coerce this. Let me do this. This is to coerce this into a primitive string. That's interesting. The homework. This is homework. Okay, this is the value of coercing this object into a string, and this is the value of coercing an object into a number value of, which will say, hey, this is not a valid number, value is not a function. Okay, so you can have access to that. That's quite interesting. So despite that is this, you value of, all right, it say, hey, this is how you can get this value here. All right, if you say this another homework and the value of this, this will give you is now this current value, and define getter, define setters, lookup getter, and the proto. But for historical reasons, now it has all the way up to that, which is now the object, and here it has pointed to null. So this particular property here defined, get prototype of, set prototype of, get and set, returns the value of a property, set the value of a property, delete and own property keys, list of the property keys, return a list whose properties are all own property keys. So if I say no homework own property keys, that property doesn't exist. All right, and then you have now what the method of functions contains, which is call and construct. Because you define now a function, if you define an object that is a function which is callable, it has these two internal methods. Along it is prototype, because the prototype is a characteristic of an object, similar to the this is a characteristic of the functions and closure, the prototype is a characteristic of the object. Mhm. Invariant essential internal methods, well-known intrinsic objects. Oh well, this is, yeah, as we mentioned here. But this is the prototype attribute. Value, writable, get, set, enumerable, and configurable. So because this is part of the objects here, all right? Mm-hmm. So object of create an object that is not prototype link anywhere. And it is purely just a standalone object. In some circumstances, this might be preferred. Exactly. In some circumstances, this might be preferred. Mm-hmm. The assignment to topic create a prototype of that name directly on other homeworks, and there is no effect on the topic property on homework. The next statement then access other homework topic as we see in the non-delegatable delegated answer for that new property, math. Figure 5 show the object properties after the assignment that creates the other homework topic property. The assignment to topic create property of that name directly on other homeworks. There is no effect on topic property on homeworks. Mm-hmm. So this is how you describe this, and the other is that this revisited. But in my case, it's like, no, another frankly more convoluted but perhaps still more common way of creating an object with a prototype linkage is using the prototypal class pattern from before class. See chapter 2 classes, what's added in EX6, and we'll cover this topic in a more detail in Appendix A prototypal class. And that this revisited. We cover that this keyword early, but it is important, but that it is in true importance shines when consider how it powers prototype delegated function calls. Indeed, one of the main reasons that this support dynamic context based on how the function is called is so that method calls on object which delegates through the prototype chain still maintain the aspect this. So in other words, when you have this, we define is a function as a value here, all right? And because here, this is like defining as a function definition, but because here is going to try to have access to the value of that live inside of this execution context, okay? So later on, we define is now an object here called homework, where here homework now we're defining is dynamically is a value called GS, and then now call that study here. So because the value of this is determined at runtime, which is when the function is called, you want to see if when you call this function, you have access to this topic. And because here is when things becomes obscure, since it requires you to understand that most of the time this is just a simple line of code in JavaScript and so on and so forth. But if you have now a huge gigantic objects where a lot of things are mutated along the way, please study GS. Please study GS. And then you also have now another math work here, okay, and say, hey, I already add the topic here, and by the time that I call this function, and this function is this definition that live here, all right, and the value of the this is determined at runtime. So this execution context, when you call this, for example, like this, is like you are providing is the data on the left as the execution environment. Therefore, is this a two object GS homework and math homework, each property linked to a single homework object, which has the study function GS homework and math homework, are each given their own topic property. See figure 6. So what happened here is that you are creating now is from the homework, all right, you are creating now from the homework is so you are creating so you have access from the homework is to this method. So you're creating JavaScript homework and math homeworks to have access to these methods from JavaScript, from the homework here. So this prototype chain, which is a way of how you can have access to prototype an object, is this. So homework study delegates to homework study. Homeworks, the GS homework study delegates to homework study. Delegates. This is interesting that they mention delegates. So the JavaScript homework study functions delegate to homework study. Oh, it's delegating here. Delegating, but is this topic for that execution resolved to the JavaScript homework because of how the function is called. So this topic is JavaScript. Similarly, for the math home study, is delegating to homework or is having access. In my case, I do things like this. It's like having access or is delegated to homework study. Okay. Because it's and when they say delegating is they don't have that functionality. Okay. So because they don't have that functionality, they're delegating is to the parent class. And they now that this is resolved to that there when that function is called. Unlike many other languages, JavaScript, this being dynamic is a critical component of allowing prototype delegation and indeed class to work as expected. The intended takeaway from this chapter is that there is a lot of more JavaScript under the hood that is obvious. So from glancing at a surface, as you are getting started learning and knowing GS more closely, one of the most important skills you can practice and build is curiosity. Exactly. And the art of asking why. When you encounter something in the language, even though this chapter has gone quite deep on some of the topic, many details have still been entirely skimmed over. There's much more to learn here, and the path that starts with you asking the right question. That is not the right question. That is not the right question. Asking the right question is a critical skill in becoming a better developer. In the final chapter of this book, we're going to briefly look at how GS is divided as covered across the rest of the You Don't Know series yet book. Also, don't skip Appendix B on this book, which has some practice code to review some of the main topic we cover here. So we look at the Appendix B and practicing comparison. Let's practice working with value type and comparisons. Chapter 4, Pillar 3. Where where coercion will be invoked. Schedule meeting should should take a start time in 24 hours format as a string, like this, and a meeting duration, number of minutes. It should return true if the meeting falls entirely within the workday. Okay. According to the times specified in dayStart and dayEnd, okay, return false if the meeting violates the work day boundaries. Okay, okay. So this is just to check. It should return true if the meeting falls entirely within the workday, according to the time specified in dayStart and dayEnd. Return false if the meeting violates the work days bounds. Okay, so you have now this, and this is a scheduled meeting. All right. Okay, we're gonna receive now the start time and the duration, and we're gonna use that to compare that. Practicing comparison. Schedule meeting here. Is fall, is fall, is fall, is fall. So we're gonna receive is a string and a number, and we're gonna return a true or false. All right. So to determine that, we can say is that, hey, if this belongs to this range, right? Practicing comparison. So you get this and these two, both of them are strings. They have the same length, which is good. And what we can do is to compare that, right? For example, because the comparison here on the string is something like this, I say, hey, because the comparison here on the string is per character, right? We can compare them into this, right? Why this is true? Why this is true? Because what is doing behind the scenes is when now that comparison is invoked, it say, hey, if both of them are strings, I'm going to compare if they have the same length. I'm going to compare each one of them. If they're not, I'm going to return now false. If they have the same length, what I'm going to do is to compare that based on their Unicode points. B, 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 right? So this is a star, all right? We can say something like that. We can also even compare that with greater or less. To say, hey, is this date is greater? So this is true, this is true, this is true, because now it's comparing is with all of this code. It's comparing this sequence string by string in their position, and if they have the same code unit, good. And because this comparison is based on this Unicode characters set Unicode set character, that's why it's actually working here. So far so good, right? So far so good. So we can now compare is that. All right, we can say, hey, if this is here, if they will receive is this, or in other words, say something like this. If the date, if the date that we receive for some reason, this one, right? We also include that. If the date that we pass is this, all right, or is greater than that, that'll be good. All right, this is one particular evaluation. So all of this now resolve is into true or false. How do you know that? well, if you take a look now at the comparison, uh, compare, lovely. Anyway, let's take a look at here. I do think is statements here. The no is the abstract operations on the testing and comparison objects, right? Such as the less and equal is less than, you know, and then is both of them now in a string, okay? If both of them are now a string, so assign is the length, and for each integer, I'm going to now is compare it as numeric code unit as it is. And if for some reason one of them, so for some reason if this character is this code unit is less than this code unit, so return true. In other words, this is less than. If not, return false. So this is why these things actually works. All right. This is why these things actually work. So the less here is how it actually solved this. It's gonna return is now true or false. Okay. So this is the reason why this actually works the way it is. Okay. And the other is that because it's going to return true, all right. And since we want to compare that in between another range, we want to say something like this. If this is true, right, I want to now is also evaluate this value, which is hey, let me now compare that is this is if, let me do this way, you know, if this is true, all right, and now you can think of this. So the point here is that I'm going to now compare is this two string. I'm going to get the start time and the duration, where this start time is say, hey, I want to compare that if this is less than this, greater or equal to the day start, or less or equal and less or equal to the day end. All right, that's what I want to do first. If it is, all right, now let me calculate that. Okay, so let me now see if by adding the duration in minutes, which is adding this, so the start time and the end time of that meeting. So what I can do here is this. I want to get is this. I want to now have the store the value here. I want to now store the start time and the end time, all right? And then I want to compare if that start time is the same as the day start, is greater or equal to the day start, and if this the end time is less or equal to the day end. That's simple. It's pretty simple, right? So there are several comparisons here. Okay. So it should return true if the meeting falls entirely within the workday. All right. According to the time specified in dayStart and dayEnd. So what I wanna do here is to somehow compute is the start time and the end time, all right, and check if that start time is less or equal to the day start, and then now check if the so now I know that is between the range of the day start, okay, and I also want to see if that meeting is scheduled at the day end. All right. So so the thing here is that I have a couple of things here. I have a couple of things here. I have a couple of things to check. One of them is start time. Is the start time is less than day start? All right. The other condition is the start time is exactly is the start time is greater and equal greater or equal to date start. Okay, it is valid, you know, it is a valid meeting. The other is the start time is less exactly. Okay, okay, good, good. This is to determine if the meeting um, is a valid meeting at the start time, right? Valid meeting without considering duration. Okay. So start time is greater or equal to the day start. The other is a start. Okay. So if the start time is greater or equal to the day start, I'm validating this meeting without considering duration. But if I do want to consider duration, okay, what I can say is end meeting, okay, which is or end time, okay, which is includes the duration. All right. So I want to see if that end time is less or equal to the end, right? So if I have this, all right, that I'm considering if this is part of the range, okay, start time is greater or equal to date start. So I'm validating is just this particular range, but I'm not considering is if that goes beyond. So I do need to consider that. All right. If the start time is greater or equal to the start, and all right. Mm, so I'm validating is if this, right? So I'm validating is like if this date move in this range, and the other is the end time, which is validating if this move from that, right? So if the start time is this and the start time is this, moving in this kind of directions, okay? So if I start from the silly example, from the base case, or from the naive approach, which is the start time, so if I say this, the start time is greater to or equal to dayStart, okay? I'm considering is that all of those start. I'm considering is this subset of valid possible schedules, right? Which is good. But I'm also considering is something that goes beyond that, right? So 80/80, 80/45, blah 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 blah. So this is one range to see, to check that. Okay. Exactly. So this is one range to check that, and the other is that I also want to verify that if the end time, which is including is the duration, is less or equal to this, all right? And if both of those conditions are met, then I can say this is true. If it's not, then return false. So in other words, we can say is this, all right? Start time is greater or equal to the dayStart. It's going to include all of those subset of elements, including those that go beyond. And with the end, I also want to check if that is from the dayEnd, is from the end of this subset to this range, right? So if if both of them now are true, it means that, well, you are in the particular range, you are in the workday bounds. So if we take this, right, and if we say something like this, so what we can say is let's gonna say start time and define here the end time, right? End time that include is the duration, all right? And because the way how can we compute this duration here is by adding these characters, which is coerce these characters and add this to the string. So to kind of merge that, okay? To kind of merge that. Okay, so if I want to compute this, if I want to compute now the duration minutes, okay, with the start time, since this is a string and I'm going to receive now a number, and what I do here is like operations, okay, yeah, because I want to do now operations here and say, hey, this is the particular this is the particular okay, this is the particular day that we're going to receive, followed by a number. So to compute this, all right, so in order to compute this, we can say, hey, if you do this kind of stuff, right, plus a 15, what it's gonna do is to this addition or this string concatenation is going to now append that. So this perhaps might be, this is not what do we want, all right? And in fact, we want is to now somehow is to compute that, to get those values. So if we transform this now into a number, it will say that, hey, I cannot convert that into a number because it's not a valid string. It's not a valid number. Okay. But here's what it can do. Okay, here's what it can do. We take this string and we take now the number, all right, and the uses of equality and relational comparison operator, and how coherence impact this code. So once you have that code works, compare your solution to the code in suggested solution at the end of this appendix. So because this coercion, what it's going to do is prefer a string concatenation. Exactly. And most of the time here, we are assuming, okay, here we're assuming is this duration is here. Okay. Now it comes to calculate and to compute this number, dates, and the string, or the number string and the number here. So well, one way to do this is both of them are a string. So this is a string, and I want to see somehow is to compute them. So the way of how can I is take that is by, well, split this element, all right, into a, so take this sequence, of elements, so take this sequence and split that based on this. So in order to calculate this, all right, so in order to calculate this, in order to calculate the end time, okay, so we can split the collection from here, okay, so we're going to get that and get this value like this, 7 and the zeros, all right, or whatever value you get there, okay. And now, okay, which the first is the hour and the second is the length, is the minutes, okay. So and then, okay, you say let's go to, so take the seconds from the array, take the seconds from the collection and add the duration minutes, right? So if this value is greater than 60, all right, yeah, if this value is greater than 60, okay, yeah, if this value is greater than 60, get the model, okay. So if the value is greater than 60, get the model of that. So get the model of the calculation. So if the value is greater than 60, okay, so what you're gonna do is to get the model of the calculations. so you can know is how many times you need to add to the number, so we know how many times we need to add to the hour. Okay. Exactly. If the value is greater than 60, get the model of the calculation, so we know how many times we need to add to the hour. All right. We add the value. We add the hours. We add the hours to the hour. Okay, so in order to calculate the end time, we can split the collection from get this value like this, where hours is the value in the first position, right? Is the array in the first position, and interest, and where hours is the array in the same position. Let hours is the array in the zero position. Let seconds is the array in the second position, because we're expecting is this format. We are making some assumption here. We are expecting this particular format. Okay, this is part of to consider, things to consider. Okay. So consideration or assumptions, in this case, to say, hey, start time must come in this format. It can be this, right? Or this. Okay. This is one of the assumptions that we're doing. Then you have now the start time is right here. This is part of the logic here. But in order to calculate the end time, we can split the collections from to get the value of this, for this case. Okay. Here, consider this example, right? We're gonna put here. Consider this example. So here you get this, right? In order to calculate the end time, consider these examples, N50, right? So assumption, start must come in this format here. The end and start time is greater, exactly. So consider the example this, right? And we get is this, start time is greater or equal to the day start, valid meeting without considering duration. End time included duration is less or equal to the end day. In order to calculate the end time, including the duration, we can split the collection from here and get this values like this, right? Let hour is array 0, let second is array 1, okay? In that position, and take the seconds, and takes the seconds and add the duration, sorry, this is minutes, exactly. So take this, take the minute and add the and add to the, you can define another variable here. You can say, hey, let duration is minute. Okay, let duration is minute, and yeah, let duration is minute plus duration minutes. Okay, so if this value is greater than 60, all right, so if duration is greater than 60, get the model of greater than 60. Let duration hour be the model of 60, the model of duration, be the model of durations by 60. So we know how many hours, so we know how many hours to add to the hours. Okay. And here you're gonna do is, well, add duration hours to duration. Okay, so far we already have computed is the mod in that regard, right? We already compute that. So what left is to actually is now transform those values into a string. Okay. So how can we transform them into a string? Well, by now, knowing the length of a number, okay, exactly. So by now, knowing the length of a number, in other words, is to say, now I want to is coerce those values. Let the duration is minutes plus 2 duration minutes. Okay, if the duration is greater than 60, let the duration be the model of duration. Exactly, if the duration is greater than 60, let the duration be the model duration hours here, and let duration minutes be the duration divide by 60. All right, this must be is an integer division. So for example, if you have now something like this and you say 30 mod 60, in order to understand this, you say this, something like this, say 30 divided by 60, we're gonna give you this, but in our case we want to say something like this. All right. By 61, like this, exactly, with the model of that, and be this, something like this. So you're going to get is now the numeric, the integer part. Let the duration divide by 60 and get the integer. All right. So now that we have that, the duration in hours and minutes and so on and so forth, it is time for us to construct now into a string. So in other words, is now coerce that into string. So now let duration string, duration minute string be the duration minutes exactly. If that gives you a evaluate the length, exactly, evaluate the length to add zeros that match the length of 2, pretty much the same to the hours. Let duration hour minutes be the duration hours, be the duration hours. All right, so now that we have is the particularly string, we can now is compare that string as it is to say, hey, we can is compare this end time here. So we can say is start time is greater or equal up to the day start, okay, and now the end time so here you have is the duration minute string, duration minute hour, and here you're gonna say is let the end time, all right, concat is duration minute string with duration minute hours, and now we can actually do this, right? And this is the algorithm here in order to calculate and compute that. Smart enough, this fella. So the implementation will be later on. So that'll be for this video. Take care. Bye bye.